a Flux model which runs on 8 GB of RAM. Basically, I'm going to provide you with this notebook where you can run the entire Flux model, which is text to image model. A quick intro to Flux. Flux is an impressive text to image or image to image model by this is been created by Black Forest Lab, created by Stable Diffusion. Flux can be seen as a successor for Stable Diffusion. They use two pre-trained text encoder, which is Clip and T5, and uses transformer based DIT model for denoising. The use of variation encoder VAE to perform denoising in latent space rather than pixel space is similar to Stable Diffusion. So here is the diagram for Flux image here, where VA decoding is done and a lot of things happen in between. The diagram you see T5 encoder and Clip encoder. Basically this take the text prompt and finally you get the image right here. The Flux has released three variant. Basically the first one is the Flux Chanel. It's open source, available on Hugging Face. Again, Flux Dev is also available on Hugging Face with non-permissive license, and Flux Pro is a closed source accessible via API. So we're gonna use the Flux. First we'll check the environment setup. Basically I'm gonna go to change runtime and I'll select T4 GPU and save. Then I'll check if I have the NVIDIA in my Google Colab. Here, let it run. It takes a little time. This is basically connecting. Okay, it got connected. Now it will run. Okay, we have the NVIDIA RAM. First we need to install all the necessary things: the diffuser for Flux model, transformer, accelerated bits and byte. This allow you to run this model on consumer hardware. Basically this is a quantization model, so we will install the transformer, accelerate, and bits and bytes. Pip install upgrade. This will again take time because these are pretty big libraries. This has completed. Next thing is we will install the diffuser. Again pip install, and this is a URL for the diffuser. Okay, it's building the dependencies. We also need to check if what is the RAM utilization. I can see the GPU RAM is not being utilized. We still write a flush function which will clean up the GPU memory in case if there is any, but I don't see anything here. It will easily run. Give me one moment while it runs. Okay, it is clean. Next is we need to get the Flux Dev model and with the transformer T5 encoder model. So when we run this, it will download the model from the Hugging Face. This will take some time because it's a huge model. So it is of 6 GB and currently it's downloading at 40 Mbps per second. Don't worry, this is getting downloaded on the Google Colab, not on your local machine. It won't use your internet. It is getting directly from Google to Google Colab notebook. To speed up the process, I'm gonna cut the video here, and once it is downloaded I'll start again. So far we are not using any GPU RAM here, which is 15 GB available. The system RAM is 12 GB, which is used only 2 GB. Next thing is we need to load the pipeline with T5 text encoder only. We will load the full pipeline from hub, but we can see we don't eventually load the transformer model VAE encoder. which is a variational autoencoder. We also need to enable CPU offloading for the pipeline, which means that if some parameters are too large to be loaded into GPU, then it will be sent to the offloaded CPU, which is done by this line. Okay, my model is completely downloaded. So far no error. Let's move on to the next line. I think there is one more model coming in, which is text encoder. Okay, it's completed. So let's run the next line. This will again take a little time. If you see, the GPU RAM has been used. Achha, you don't have access. Okay, I think we might have to log in here. Give me one step. In order to download this particular file, we need to first log in. So notebook login has to be made on Hugging Face. You need Hugging Face token. So if I go and got it. There should be some setting here. This is not how it is. Here we are on the Hugging Face. Let's go to settings, access token. Validate and refresh. We can copy, paste the token here. This is successfully logged in. Now we can run this model. You will see the GPU RAM going up again. So far it is flat. Okay, now in order to get a good prompt, okay, I'm gonna use the chat GDP. Okay, give me a good prompt for a beautiful girl playing in Diwali, bursting crackers and Bollywood celebrity So on vibrant Diwali night, a beautiful guest was starring in traditional outfit, his joy bursting cracker with laughter echoing the air around her. A group of Bollywood celebrities clapping and cheering, their smile light up the festival atmosphere. Colors light twinkle in the background as they capture joyful movement and surrounded by spirit of celebration and togetherness. Okay, I'm going to copy this and paste it here. Okay, I'm going to run this. We're going to go encoding. So far, you see the GPU RAM is picking up. Okay, the this is completed. When we check the prompt shape, the top size is 1,256,4096. Okay, now here is where the pipeline will be executed. So I'm going to run this. It is actually downloading one more model, which is Diffusion PyTorch model, Safe Tensor. Okay, the number of inferences, I'm going to reduce it to 20. This is again 6.70 GB. I see so far it is only 6 GB of RAM that has been used. I'm going to speed up the video. So far the system RAM and the GPU RAM is stable. Pipeline is still not executed. You can see the RAM is picking up to 9. We have 15 available. 12. I hope this doesn't crash the Google Colab. Okay. So it's going on pipeline. So far we are at 12.8 GPU RAM. Okay, the pipeline is done. It's offloading. Cool. Okay. So we have changed the number of inferences. Step is 20. Let's run this. Okay, it's running the pipeline. The image, the denoising will happen now. Okay, it's 7 steps so far out of 20. Okay, the GPU RAM has reached 13. Image is already created. If you go here, and you refresh, you will see an output image. You can also download this image and that. or you can also view it here from pill. We will just run this code and the image output will be here. Thank you for watching.